I'm living my life, guys. Today's date, project name, save project as what? Human rights and Sige. No, it's not a Sige. It's something else. It's OpenMotor laptop. Open laptop. Let's call it OpenMotor laptop. OpenMotor laptop model. Pi money. Basically, guys, I'm recording this. Oh, it's recording. Okay, literally, this is a voice recording, but it's basically dumb, really dumb. This is just the AI system. But look at this. Is what I'm saying. If I got this in a video, yeah, so basically, this is the one first interaction I've told you we're gonna listen to this article, but I hope it just makes sense to me. Because I don't want to be talking to it, but in a way, it's always just doesn't stop anyway. Basically, this article is we're gonna use for open model, but it's like I got my open model too, but I don't like to this model. So basically, your hand is a dimension. It's definitely a dimension. So your hand is a dimension. That's what you understand. You can't separate your hand, your physical hand, from your dimension. You cannot, because you are your own God. You have 4 fingers on each hand, 1 thumb. Thumb is half a finger. Any thumb, left or right, and projection or not, up, down, is middle finger. But if you look at these are hands. I'm still handsome, guys. I'm still black. So, literally, if you're living as, literally, let me give you the deal. We live 3 plus 3, 6. 6 minus 1. That minus 1 is a half. This is 5. That's your thumb. 5. So you have 4 fingers. 4 fingers and 1 thumb. That thumb is not a finger. And that is the 5. You get 1/2 of each doing 1 thing. So each starts with a half. So you have 1 literally. So it's like a digit. This is a digit. Let's get a finger model. A finger. Hands. Let's get full hands. Hands. So basically, you see this kind of model. You get this how to draw hands. But literally, I'm trying to draw hands. But I'm trying to draw hands in real time. So it's basically a tracing system for the hands. But that traces your hands being projected. So it's tracing your hand in real time. So basically, it doesn't your signals your hands. So that's my impression. So let's watch the drive video of this.
This house. Wow. And what do you pay?
Fucking ass, man.
Dave's just used confused.com, so the thought of car insurance no longer weighs him down.
I don't care.
I don't want this.
Insurance feels better when you've just used confused.
My thumb, and then I'm just going to define in my thumb.
Basically, it's tracing this in 4D. So basically, I'm trying to protect my hands. Basically, you see the camera facing me, but I'm using my hands. So basically, I'm the camera. My hand is the camera. I'm making the motion, but the camera is facing me. So I said, with space and time, and the doesn't matter how I do it. I'll get the time of the space and space time because the time, my space of the hands is 1 dimension, and dimension can be measurable at the time. Shut up, Jaron! The space is my little dimension, and it's like some of the lines I have. It's kind of a dimension one. It's literally just a hand, but this is 1 of 0 dimension. This is 1 dimension. And this one, if you don't have this thing, that's gonna be this joint is just 1 finger. This is called what? A pinky. A pinky. Now this is called a middle, but this pinky is 2 half of dimension. So it's 1/2 plus 1/2 because it's 2 connected. There's 2 joint. Some people have a lot of motor problems when they don't stretch their hands, and that's kind of you have joint issues. They lose most coherence or possibly. Keep quiet, Jordan. But you have to do it. Jordan, keep quiet. Jordan, shut up. I don't give a shit at me now. I'll clean up when I want to. I'll clean up when I want to.
No, you can't do that. Everybody shares a kitchen here.
I don't give a shit to me now.
Baba!
Look, so basically, in the best case, it's like a 1 jump, half jump. So it's like a 3rd jump. You see, the way you can bend your hands, it's basically, wherever you can bend your hands, it's a third. So it's a third. So it's a third. So you got 1/3, 1/3. So I can bend my hand 3 times, my finger 3 times, and that's basically a third. See, this is called this 1/3, the dimension of a third, sorry. Not half. That's a third. So 1/2, 1/3 plus 1/3 plus 1/3 equals what? A third. But you know, at the 3 over 3, that's 1. This is 1 pinky. 1 pinky, now 2 pinky for 2 controls. But this is my right hand, this is my left hand, this is what I want to use. So this pinky is kind of, yeah. But you know, when I make some motion, these are joints like this. You have to track all the dimensions all the time. So this is because I'm moving 2 axes at a time. Because I'm operating at 2 axes. Well, this is 1 axis, this 1 axis this axis. But this left, this is the axis I'm operating. This left hand, this is my axis. So if I do something on side, rock sound, I should know it's rock sound. Because you know, instinctively, not instinctively, I know it's rock sound, but my computer doesn't know that. Because I'm making the rock sound, I'm just trying to get the horns up, but it doesn't know the horns are gonna be horns. So you can know the horns are gonna have this configuration, and that's the real goal of it. So the kind of thing I'm doing is okay. Your peace out. You know, peace out. I don't know this. This is peace out. You know, I just thumbs up. This is okay. This is down. But look at it. It's all changing the microcontroller. You see, my hand doesn't break. It doesn't break. It just flexes. That's gonna do the AI is trying to solve. But they're using wrong. They're just giving AI the control of your hand, and you should never do that. Literally, you should never give AI the control of your hand. You're not gonna program anything. That's why my system is 4G for 4 dimensional. So you can basically the 4 dimensional time anyway, but you have all the space in the world for the time you're doing the operation. So you share a quarter of the dimensions in each 4 dimensions. So you get 4 divided by 3, which is what? 4 divided by 3 is 1/3. But actually, this axis 3.3 is 1/3. But let's say 4 divided by 2/3. Divided by 2 over 3. 4 divided by 3 over 2. 2 over 2. And that'll be 0.4. 0.4. But it's literally just 1, 2, 3, 3/4. Notice this thumb, this big thumb is 1/3. But you know, 1/2, 1 2 split half. I can only bend. Oh, this in thirds. So I can. Oh, there was a joint. That's a bend. So I'm gonna calculate this right probably. So this is you can bend it twice. You can bend this thumb 1 down. And not down. And this is 2 joints, so this is all thirds. So you get a third, basically a third times 5, a third times 3 to the power of 3. So a third to the power of 3, because that's 3 axis of dimension. There are 3 joints can be moved, 3 motor joints can move in 1 dimension. A third to the power of 3 is a third plus a third which you get 5 fingers. So that's 5. That's 5 to the power of 3. That'll be 3 dimensions. But you control each individual joint. That'll be 5 to the power of 3 is 5. Because 5 times 5 is 10. 5. This configuration. This is just the joint motor joint control. Because you'll be this thing I'm saying. So I control everything like without anything dropping. But it's an IK principle. This is I cannot control. You know, but I look forward to control ahead of time. So there's space for this now and space for ahead of time. Basically, you have 2 kind of ways to do it. So you can have the space now, okay, for, and the space ahead of time. So this thing is how to find joint movement motion. But you do that times 2. So that times 2 would be 250. So this would be 250 divided by 2, which will give me 125. So this 250 in total. At which one point that something can discharge and do their own thing. Like one finger can go their own way, you know, like a little piano. But you know, it's kind of like the goal of this thing is just to give you the full form of them. So this can basically, I'm drawing hands because I'm just tracing my hands in 3D. And so I can project it into the computer system. But my hand is the hand of God. You want to use one hand at a time. In case you one hand on your side, you want to draw one hand at a time. Because that's the way simply what you do it. All the missions are based on the kind of the.
Just like this.
It's like a.
Shape
Mina,
my
solve your problem.
thumb.
Mina, solve your problem. So it's like you try to trace your hand, but you know it's a staggered pose. It's a stop pose. Basically at each frame it's a stop pose, and that form is actually meaning. It's like smooth color, like what do you call that kind of smooth? This is the general way to do it, kind of general way. But you never use honestly. We should never use what front. You should always use circles because circles wrap around the fingers. Against any pressure things that happen. So you get the pressure mechanic there too. These kind of things are annoying me. It's really annoying me. Keep quiet, man, Mina. Mina, keep quiet, Mina. So this kind of trying to do this program is like a study of the HAL archive of 3 dimensions. But HAL is annoying because HAL is doesn't really account for the dimension. But you get 250th dimension in space and time at one time. But that's not the time equivalent. That's not good enough. So I have invented a way to do it. So wonder if this is one dimension. If we get 125 configuration in space at one time, then we get 100 which is a radius of movement of axis. It's like there's an x squared minus r squared. Okay, difference of squares. Sorry, the difference of squares. So you get the difference of squares, which is y squared. Wait, what's the difference? So let's get the difference of squares. But this is difference of squares. Basically, this is a so I'm trying to plug this in. I'm gonna plug this into the radius bound tomography to show you how it works. So the difference of squares is a squared plus b squared equals a plus b squared. But this can be expressed as a squared minus b squared, which is equivalent to a minus b plus a. This is like what I'm looking for. So you get the difference of squares and the let me get to online whiteboard the same. Online whiteboard. Let's best whiteboard. I bet you so this is like x squared, because it's like a little what I'm saying. It does that because you know question. Is you get the difference of square, which is a squared. Look at it, go through here. I can't even put it in my mouth. It's like a William Climber. So if I'm supposed to use one hand, you know, there's some kind of motion that's so mechanical. It's your hand. It's just like I'm taking what I call taking a left on. You know, it gives you energy, like taking two, like it gives for example, there's some hand movements, some gestures you have that give you full control, and those gestures are in halves only, a third to a half. You know, because if you don't know something, you have a third of instruction, and you try to go back, you do half or something else, you check the last step. And this is so, for example, if you take one electron, if no one gives you an electron, that means you're giving you power. Are you okay, Mina? I don't do shit. So, so literally, if someone gives you a electron, that means they're giving you power. But you don't want power. You want the control. So that's what I'm saying. You don't want the electron. You never want the You want the power. So the electron is like a potential solution to the problem in an active system. That's what I'm saying. The electron keeps on giving you electron. One electron is half a power. Literally, but you know, half a power means potential power, and that's the kind of power problem it is. You can use that power without even knowing you have the power. So you have like an energy distribution in that way. For example, so let me start. A squared plus b squared equals a plus. Anyway, so literally, it's like giving them the palm. So you get it's got a difference of squares here, which is x squared plus minus squared, which you get a range of that value. But the so if you give you an electron, that means give you an additional mass. So now you mass is like the mass of you get an anti-electron, which is electron is something in a waveform. It's probably in waves, but it can be in mass too. It can be it's an electron really, but in a mass form. That's the form. So it's just a negative charge electron, but it can be in an energy state of a proton. If you have axis rotation of from the left to the right, you have to go counterclockwise. So you go minus 90. Minus 180, minus 270, and minus 360. That's half a power. I mean, that's half a power. But that half power can be negative half as well. Because you can lose that power too as soon as you get it. Because it's not fully warm. It's not fully. That rotation of minus 360 has to be minus or 360, depending on the axis you're on, your point of origin, where you're looking from. Where you're going, where the northeast, where the south bank is. So if you go south 180, you got to go half, but that's a quarter of the energy step you are in. So you have half of the power and have the power to act. So that kind of 90, if you flip the basically that is like energy state. So if you have half the energy, to do something. But you're not able to do it, yeah, because you can't. You only have the hours you do it. You have to do something else. But you know, it's like an action system, no matter. So the third of this finger is a signal, literally, because the third of the finger is like place the third, 2/4. We can take 2/4 of the finger and do one thing. So that's what I'm saying. So 2/4 of the finger can just go do one motion, one swing motion, and that's the real power of the left arm. So you get 2 left arms to 1 right arm, one proton, get 2 left arms, which is one left arm to 2 positron. So you have to rotate 2 times in that configuration. I can't remember what I'm saying. It's like a difference. It's like one difference. A squared minus b squared equals a squared. But this was basically you get the polar this squared this squared is very universal. But I'm gonna try ask ChatGPT to do it without asking ChatGPT to do it properly, because I'm gonna ask ChatGPT to do it my way. So let me try to get this to so this one squares basically let me just try to I'm trying to so I'm gonna ask the thing from one calculation. Formalize how to use e to the polar system. More has evolved via dimension of 3 xyz for a sparse configuration where 3 plus 3 kinematics control points via a Bezier curve disjoint in space and time for the inverse kinematics control points in the vector in the lattice space. Define how show that show these properties hold in all axes x, y. Basically, they meant to hold. Basically, they have this difference called intersection. So via the lattice intersection. So I guess let me just give them the example. So you get a half 1 divided by 3. 3 times 5 is 125. 125. 1 divided by 3 times 25 equals 1 divided also 5 to the power of 3. That's 1 divided by 3. I don't really care, but divided by 3. It's 41.67. But show how these tomography via tracing hold holding is the concept of preserving a lattice joint via all axes of polar rotation. E to the power of pi times I equals 0, where axis imaginary x, y, and z hold in still active mode, still never passive protocol, via observer, via state reconfiguration. I don't really know this one. I'm just getting on it. So basically, it's literally just because I'm trying to show you what I mean. So this is like a S squared. Basically, this is like a power function, but I didn't put a S squared on. I think I just too tired. Literally, I wait for it to. Anyway, no me. So I think I'll just get it to give me a Korean answer because I want any Korean answer because it's not really making sense what I'm doing. So I have to do that now. Let it finish, guys. It's not good to later either. But literally, it's gonna be. Oh, the voxel. I don't know what the voxel of the system is.
You can't use a stove now, I put,
You spray my food, Mina.
No, you can't use that.
Are you spraying my food, Mina? Are you spraying my food? Are you okay?
No.
No, are you okay? I'm asking you, Mina.
You don't use that. I watch that.
I don't give shit, Mina.
Don't listen to people.
I don't give shit, Mina.
Don't give you a shit after.
I don't give a fuck, Mina.
Just pray when you leave this house, man.
Yeah, I don't give shit, Mina.
Jordan, okay? And I give you medication.
So basically, you know what I'm saying, so the kind of thing I'm saying is that's to resolve this. It's like I really use the AI to do it. I'm sure right now, but it's like.
Too much clothes. Every day you come out, Jordan's clothes. Yes, Jordan. Yes. Okay, Jordan.
Literally, this is what I was doing. I'm like, really surprised. I know what it is, but I didn't have time to do it. It's supposed to be like 4 fingers on it, but it's like one time, and that's really what it's meant to be. Fourth, it's like really good. But, so this is a hand. So this is kind of Vox. I don't know Volvo, but literally it's like the innovation between the finding and the research. Literally, like, these are the papers I'm looking for. I'm looking for my one. My one's like here, OpenMotor. Is it done for getting? No. It's A squared plus B squared. Yeah, it's just, I've got this kind of thing. Okay, guys. Try to undo the A squared, B squared. Okay, done.